Today's lesson should be fairly straightforward for you, and you shouldn't have too many problems because we're just going over exponents and a lot of it is review. But that being said, be sure you stick with it all to see and ensure that you know what to do when there's a negative in the exponent, because frequently that's where students have issues. So first of all, just remembering what an exponent is. If we have 2 to the power of 3, we remember that the exponent, there, the number up top, and that tells you how many times to write the base. Be careful that you don't ever do 2 times 3, thinking that it's 6. That's your base. And the whole entire thing is called your power. So what we have here for 2 to the power of 3 is 2 times 2 times 2, which equals 8. So much different than 6. We never do 2 times 3. So here, 4 to the power of 3 is called the power, 4 is the base, 3 is the exponent, and it's expanded multiplication. 4 times 4 times 4, which equals 64, not 12. So now that we remember what an exponent is, we have rules that can help make our life a little bit easier. So for multiplication, our rule is to multiply the powers with the same base. That's key. As long as the bases are the same, we just keep the base the same and add the exponents. So we want to add. So those are sort of our key words in there. A lot of you have these rules from the past, so this is just review. So our example would be if I had 3 squared multiplied by 3 cubed, that would equal 3 to the power of 5. In general, what we would write if we had m to the power of x times m to the power of y, we have mx plus y. X in there. That's sort of our general rule. I'm just going to erase that because of space. I'll just simplify that. Our next example is for division. So if I had 7 to the power of 5 divided by 7 squared, I would again subtract those exponents. So my simplified answer would be 7 to the power of 3. So if you are keeping notes or for your study sheets that we talk about, when the base is the same, you subtract your exponents. So we often see m to the power of x all over m to the power of y. Then we would subtract those, x minus y. A power to a power is something like this. If I had 3 squared and then to another exponent, 3 to the power of 4, here is where you multiply. That's going to be 3 to the power of 8. And it's so important to remember that multiplication. So many students still add there. A lot of students would tell me that becomes 3 to the power of 6. 2 times 4 equals 8. So please keep that in mind. So if you had m to the power of x to the power of y, simplified, that looks like x times y there. Anything to the power of 0 always equals 1. So if I told you that you had 99 to the power of 0, that equals 1, no matter what it is. So with negative exponents, let's just be sure we go through here. To convert a power with a positive exponent, you take the reciprocal of the base. So what this is saying is you want to always make your exponent positive, and you can do that by taking the reciprocal of the base. So if I had 2 to the power of negative 5, and I can't ever leave my answer with a negative exponent, I take the reciprocal of the base and then make the exponent positive. Okay, 2 simple steps. Reciprocal of base, exponent positive. Distribution, if I have an exponent outside, it goes on both variables on the inside. As well if there's a coefficient. So if I had 3 x to the power of 4 y squared, all again to the power of 2. I have to be very careful that I remember that that exponent goes on everything. So I have 3 squared, x to the power of 8, 4 times 2, and y to the power of 4. So that would leave me with a final answer. 3 squared is 9, x to the power of 8, and y to the power of 4. Now that we've reviewed our rules from last year, let's pull them all together and see that we truly understand. So here is multiplication, and my base is the same, so that means I add my exponent. So more steps than I need, but I'm going to show it here, the addition. 7 plus negative 4 is positive 3. So just be really careful if you're dealing with negative numbers. Here, my base is the same in its division, so I'm subtracting them. Again, I have 10 minus 8. You do not need to show that step, which becomes 5 squared. If you're simplifying, you can stop and leave exponents in your answer. If you're evaluating, then you have to go a little bit further. And as I said that, I realized it said here, simplify, then evaluate. So here in the yellow is simplified. It's okay to have the exponent. But because it does say to evaluate as well, 3 squared is 8. So I'm going to take it down to that final step. 5 squared is 25. I have power to a power, and that says to multiply. Negative 2 times negative 1 makes for positive 2. So that is my simplified step. So if your test just said to simplify, you were done. And if it says to evaluate, then you have to go a little bit further. Bear with a few more examples here because they are so important. So even if you feel like you really have the hang of it, stick with this just to the end of the video here for a few minutes. So power to a power says I have to distribute this 2 in. Don't forget to do it on the coefficient. Oftentimes that 3 would get missed. So I have 3 squared, x squared, y squared. And then this is still all multiplication. So this is negative 2 x squared times y. So my next step here, I have 3 squared, which equals 9. And then 9 times 2 is negative 18. My bases are the same for the x's, and this is multiplication all the way across. So where your bases are the same, you still add your exponents. And then there's a 1 up here, don't forget, that's not a 0. So y squared plus y to the power of 1 equals y to the power of 3. And then that question is finished. Here we have negative 2 to the power of 4, x to the negative 4, and y to the positive 4. So if you wrote negative 2 out 4 times, because that exponent is even, you are going to get positive 16. I have a negative exponent, so I need to be sure I take the reciprocal of the base, and make the exponent positive, and then y to the power of 4, because the exponent is already. 16 times 1 times y equals 16y4, all over x to the power of positive 4 in the denominator. And now that question is done. There are 3 examples there that I think that you can read. Do the best you can. I'll just rewrite them in case you're unsure here. Your question D is 2x negative 1y to the power of negative 2. These are for you to try and bring into class tomorrow. 27x cubed to the times y, 9xy squared. I'm going to make that a dot so you know it's multiplication, 2xy. And then your final question of F is 5x, 3 minus 1 squared. All over, sorry, I'm just being sure that I read this as well there, 2x, 2a minus 5, x, a minus 3. So do those questions and bring them into class tomorrow, and we'll be